Hello, everyone. Thanks for joining us today. My name is Henrique Mendonça. I am a lifecycle designer at eTool, and we'll be discussing today about benchmarking and target setting, building lifecycle carbon emissions, the whole building lifecycle carbon. So I'm sure we all know why this is important, why it's important to reduce carbon, but we often ask, why is this important to our clients? We have been involved somehow with one of these motivations for reducing carbon. We know about the declarations, the architects' declarations or engineers' declaration on climate emergency, bringing the topic for worldwide attention. We have government agencies and organizations with social and environmental responsibility programs. There's often increased inefficiency and cost reduction related to reducing carbon as well. So there's a financial incentive there. We are seeing as well an increase in regulatory requirements worldwide amongst the projects we work with, as well as our users. The adoption of LCA and carbon accounting in rating systems is also picking up. We see more relevance for those credits, increased relevance, and additional credits as well to target carbon reduction at early stages. So that's also important to our clients if they're pursuing green rating systems. We're seeing now, especially post-COVID, economic recovery plans that they require certain performance for you to access grants and financial support. So we have seen recently increased demand in early stage analysis for funding approval and risk mitigation. And also branding innovation, which is more voluntary motivation for clients that are a step ahead of the others. So I'm sure you all have similar motivations when working on your projects. If you have any other idea or market that you're pursuing, please, feel free to send a chat. We'll keep this very interactive throughout the presentation today. So the idea here is to discuss initial project engagement with LCA. So just at project kickoff, when you at concept stage and you're thinking about your project, you buying the land and starting your design process. So we're looking at benchmarking building lifecycle emissions compared to similar buildings, similar typologies. And we also look at how you set goals and you set impact reduction targets early on to inform the design process and help the design team. So this is a quote, very common quote that we're getting recently from our clients is, I want my portfolio, I want my assets to be carbon neutral by 2030. So this is beyond the organization level. This is now the assets in projects that clients and architects or developers are working on. They want to turn those projects carbon neutral by 2030. But this is a very broad statement. We need more details on how much carbon is in the building. How do we measure it? What methodology we're using? What scope are we capturing? What quality of data we're using? How comparable those results are? And also what you're going to use the LCA results for, so we can tailor the reporting and the results format according to the application of the LCA results. So these are questions that we often ask back to the client when they inquire us to do assessments for them or to engage with their design teams. And then we explore these further. I'll go through different online content that we got, so all public available, to present the methodology. We mainly work with lifecycle assessment, so that's the eTool LCD platform is based on EN 15978, so it's the international standard for environmental performance of building, the calculation method. Sometimes we get clients inquiring about the scoped emissions. So this is the GRI methodology where you break emissions in scope 1, 2, and 3 in direct and indirect emissions. But we often redirect clients to life cycle assessment, which seems to be the trend now, where we're using for construction, environmental, and accounting. This is regarding the methodology that we discussed today, and life cycle assessment EN 15978. Then we ask ourselves, when you say carbon neutral, what scope are you capturing? And there's a pretty good article from, it's like a framework document from UKGBC, Advancing Net Zero, where they cover definition of net zero carbon. And I think this is really important to set the scope early on, so the whole project team is engaged. So here we have also an article online talking about zero carbon. What I like to discuss is, we'll break the presentation today in different scope. What we're seeing, the blue one here is the operational energy. So this seems to be, especially in the Northern Hemisphere, where the impacts are dominated by energy. For countries, you have high carbon intensity for the electricity grids. This has been the focus, the operational energy, or net zero operational energy. But once you start optimizing that, the other areas of your projects start to become more relevant. So we're seeing now more an increase in construction, in building construction scope, which is the stage A here, the orange rectangle here, capturing the construction process and products. This is module A1 to A5. And even beyond that, some clients are now looking at maintenance and repair impacts. So the impacts throughout the building lifespan, including end of life, and also accounting for module D, which is benefits beyond the life cycle of the building itself. So we are looking at these stages and asking the clients, okay, what are you trying to capture? How much carbon you'd like to offset or compensate with renewable energy, and work through the scope to define those modules with the client. After you've defined the scope, we need to define as well the construction scope. So we're looking at module A1 to A5 only, for example. Are we looking at all construction scope items? So I have here the software with the details on what I'm saying. When you're looking at the construction scope, we've got all these categories that you can include. Are you including excavation? Are you including site preparation? Are you including all superstructure items, internal finishes, and so on? So this is important to define as well with the client. we always recommend capturing as much as possible initially, and then the client can decide on if they want to offset just the construction impacts, or if they want to achieve operational net zero. So this is important for the construction as well as for energy and water. What is the scope for operational energy? Is it just building integrated, lighting, HVAC, vertical transport, or are we also including plug loads like appliances and electronics, computers and screens, water pumping? So it's all important to set at the early stage, define a clear scope, what you're measuring. The other important aspect is data quality. We have different lifecycle inventory in eTool LCD. So this needs to be very transparent for the client on your reference data set. In eTool LCD, the data sets are provided by EcoInvent, and they are regionalized with regional data sets for specific regions: UK, North America, Australasian. And we also have a data set provided by BREEAM, so impact compliant data set. The important information here is that the data, the quality of the data, the ISO compliant 14044 as well as 15804. This is ensuring your reference data, your inventory data is comparable and is compliant with the standards. Really important information that you work on reliable data and compliant data. Make sure the reports are robust and comparable. Then we ask ourselves, okay, what is the application? What are you going to use the LCA results for? And I have here a few examples from rating systems. BREEAM has a specific credit for material life cycle impacts. So this is more focused on the embodied impacts. Similar with LEED, the building life cycle impact reduction credit in the LEED certification scheme. Again, focusing on the core and structure because they have all the credits targeting energy and water. What we're seeing is that the rating systems, they're integrating different credits into the LCA analysis. We see an advancement on that in Australia. We have the whole building carbon in one model. We have operational energy, have embodied impacts as well. So we see that trend increasing throughout time. All are looking into more details today regarding benchmarking and target setting, some regulatory requirements. And this is a post we published recently about London Plan policy. Really good example about targeting reduction in building life cycle emissions. So this policy relies on life cycle assessment pretty much and defines specific targets for building applications and building approvals. There's a lot of details here. I'm just going to reference this table for now because we're going to explore it in more details throughout the presentation. What the policy is showing us is first they're removing operational impacts. So module B6 and module B7, which is operational energy and operational water supply and treatment, is excluded from this policy. So the targeting embodied impacts. Okay. This table is for an office. So the results that we're seeing here is kilograms of carbon per meter square, gross floor area of an office building. So we use today office building as an example, but the important thing to remember here is the application of the methodology. So you can replicate the same approach to different typologies. The numbers will change, but once you've got the concept and you know where to find the initial information, it becomes a lot easier to communicate with the project team. So we see here 3 different columns. One is the eTool benchmark that I'll show you throughout the presentation, a benchmark model that is available in the software. Okay. The other column here is the whole life carbon, which is the policy name for this, capturing the whole life carbon emissions from a building. The whole life carbon benchmark is the minimum requirement. So 1,300 kilograms, 1.3 tons of carbon per meter square. So this is the minimum requirement, and we also have an aspirational target for those that are willing to push the boundaries further. So when we're looking at the total results here, we're talking roughly around 1 ton per meter square. So this gives you an indication if you have a project that is 10,000 square meters, 20,000 square meters, you already have a ballpark figure of your embodied impacts, excluding operational, because operational will vary depending on location, grid mix, and etc. So starting to give you an understanding of the ballpark figure, what the impacts, the majority of the impacts are. So we're seeing a focus in module A1 and A3, the product stage, because the majority of the impacts for this scope occur at the materials and construction stage, a product stage. So you see here the eTool benchmark 600 kilograms. So half of these impacts occur at the product stage. It also helps you understand all the areas of relevance. So should we focus on transportation impacts or construction impacts, or should we actually focus on our procurement process and try to extend warranty periods and guarantee quality of our products and durability, so we reduce maintenance and repair impacts? We also have opportunity to look at the end of life impacts and understand the big ticket items from demolition and waste processing. So we can start discussing strategies for design for disassembly. But there's a lot you can take just from this table without even looking at your project specifically, because it's going to be around the same figures here. So this is one example about the application of the early stage target setting. Another example is a planning policy from Australia, a council called City of Vincent. And what they're doing, they're setting life cycle assessment as the framework for quantifying environmental performance. They're going one step beyond, because what they're saying is they accepting life cycle assessment as the framework for calculating the impacts, define the system boundary and the scope that you're capturing. It talks about the minimum requirements. So in order to get a building approval, you need to meet the requirements set in this table here. And you also need to submit EN compliant report. Usually at early stage, we put a factor of safety. So this is just to ensure you have room to change your strategies and still meet the target. So I'll break this down into more details looking at the commercial office, so non-residential building here. What this policy is telling us is that it's saying that it's 100 kilograms per meter square, but in this case it's meter square per year. Okay, so we usually calculate the building lifespan based on functionality. So building aesthetics, the likelihood of being redeveloped. So there's a whole topic around functionality that we covered on a different webinar that talks about reducing carbon and by improving functionality. So increasing the design life or increasing the net lettable area. So increasing the overall functionality of a project, even before you start discussing energy efficiency or impact reduction from materials. So in this case, if we assume, for example, 60 years, which seems to be a good period to capture recurring and maintenance impacts, we're talking here about 6 tons, 6,000 kilograms per meter square. So this is an Australian reality, and it's mainly impacted by operational energy. So I'll show you that in more details when we look at how operational energy affects the overall results. So very specific target, very clear definition on how to get there, and gives the design team flexibility to decide the areas of the project, if it's building products, materials, or energy efficiency, or water improvements, water saving improvements. Gives the design team flexibility to pursue the most cost-effective strategies to hit that target. So this is really important when you work with performance-based instead of a prescriptive approach where targeting points and credits and so on. So very, very good example here from City of Vincent regarding planning approvals. Okay, so now we have our targets and we have the application. I will show another example here from RIBA. So RIBA 2030, they have a climate challenge program where they're also setting targets to help industry transition. And this is focused in the UK, so the UK example here. But again, I just want to show you the concept so you can understand the basics and then replicate to your location and to your specific projects. So we'll look at non-domestic buildings, this table here. Non-domestic buildings, embodied carbon. And this gives you some details on the scope here, whole life carbon, following the RICS guidance. So this industry guidance provided by RICS on how to do this, how to calculate what scope you're capturing. And again, it's within that same range, 1,100 kilograms of carbon per meter square. So within that range of 1 ton per meter square. And this table gives aspirational targets as well. So how do you reduce your emissions throughout time, and how you improve efficiency before you offset? So very clear targets again on embodied carbon. Yeah. We have here the operational energy target, but it's in different unit. So I'll bring that up later. I'm just gonna show the software for a second and look at this embodied carbon example, so you know how to get started, even without having too much details of your projects, right? At the target setting level, what we do at eTool, we use the floor area as the metric to calculate the initial impacts. So this is a preliminary analysis using a benchmark model for an office building. You can see here the initial impact per meter square is very high. It's almost 10 tons per meter square, and the majority of the impacts are coming from operational energy. So we'll look at this in a sec. What I'll do here, I'll customize the scope. So we are focusing at the construction stage. So I go in here, the project level at eTool, and I have the options to flick these modules off. So what I'd like to do is to capture everything but operational impacts from energy and water. And I'll hit save here. Okay, just refresh this. Now we have a completely different result because we're excluding operational energy. It gives us more tangibility on where the impacts are, which areas of my building, superstructure, services and equipment, most relevant impacts from equipment and construction. So this is really important to narrow your analysis and give you that flexibility and tangibility. So back to our RIBA target. Now I'm going to look at the operational impact. And again, this is referencing CIB's benchmark, TM46, which is a UK benchmark. And it gives you some guidance here on improving the building fabric, improving efficiency of services and low carbon heat and so on. So it's already giving you some tips on how to get there, how to get to this transition, to this reduction, and eventually get to net zero operational. So at eTool LCD, what you do the other way around. You turn off your operation or your embodied impacts, and you turn on your operational. I'm gonna leave export here because that's related to operational energy as well. The credits you get for exporting clean electricity back to the grid. Then we will go into the software and we'll look now mainly at energy. So now we know what energy end use is taking most of the, carrying most of the impacts, and we can drill down the details here and start understanding the areas and what you can do to reduce the operational energy impacts. So as a quick reference, I've done some math on this already. Here the unit is in megajoules per year annual demand for different end use, and this equates to 340 kilowatt hour per meter square. So I just divided this by 3.6, divided by the area of the building, and then I got to 340. So again, a lot higher than the UK annual demand. So it's important to understand the scope here, as I mentioned previously. What type of operational impacts are we capturing? Now, when you look at the energy impacts, are we capturing, for example, water pumping or lighting for car parks or ventilation for car parks? Plug loads, in this case, we have a lot of plug loads accounted as well. So when setting your targets, it's important you define that. So when referencing these documents, you know you are within that ballpark figure, okay? One interesting here about different locations and how that affects operational energy is your site attributes. So which electricity or gas or water grids the project is connected to. So you remember we were at 8 tons of carbon per meter square. If I change this here to UK, both the import grid and the feeding grid, have to use a generic gas grid because we don't have a regionalized gas grid for the UK. Average water supply grid and average water treatment grid for the UK. I'm going to change all default values for the operational impacts. So again, this has reduced the impacts by half because we are in different location, different grid carbon intensity. So as I said, as you improve the energy efficiency or the operational energy impacts, the other areas of your projects start to become more relevant. Okay. So what happens if I go even further and I change this to the RIGO, the green, the clean energy, good energy scheme, where you have a lot of renewable energy contribution to your grid? We'll see an even higher reduction in your operational emissions. Just basically showing the importance of defining the scope and defining the location, because the impacts will change depending on the primary energy sources and the efficiency, the carbon efficiency coefficient of electricity grids. And this is also useful, and it's a new feature, not a feature, but a possibility for future grids. So we have introduced a bunch of different decarbonized grids using the UK government trend and policy for future projections. So we have here a list of different grids that you can use to project your transition to decarbonized grids and see how does that affect your design. And that will put a lot more emphasis on the initial constructions, because we know our grids will decarbonize throughout time, or needs to. So again, very important information here. This net zero carbon buildings framework definition by UKGBC explains it very well. What we're discussing here, the process that you can take to achieve carbon reduction. So from reducing your construction and operational impacts, breaking down in details. So I encourage you to have a look if you haven't seen this document before. Really, really useful. So I'm going to jump back in the software to give you guys some more details around benchmarking using the software. I'm going to go back and turn all the lifecycle modules on. I'm actually going to focus on, a lot of focus has already been put on operational impacts. So I'm going to take this opportunity to focus on some of the initial construction impacts and end of life impacts instead. Okay. And show you some of the new features in the software that you can use to evaluate initial performance or initial impacts. What I'll do, I'm actually going to remove end of life impacts and module D impacts as well, just to capture A1 to A5, which is the carbon we need to reduce right now, right? Is the carbon that we embedded into our buildings today. Okay, so back to our design here. What I'd like to show you, now we are at 770. So back to our table here, we're looking at A1 to A5 only, right? We are capturing the initial impacts, and they split between product, transport, construction. So out of the 770 kilograms, where are the biggest impacts? We can use the analysis tab here, which is a new feature in the software. It breaks down, it's a pivot table, breaks down the impacts, and you can customize. So you can look at the top impacts by materials, for example. And we see here concrete, obviously, steel. We're starting to see some different elements here, like refrigerant gases from chillers and heat pumps. And we have other materials here, like aluminiums and recurring impacts. So maintenance impacts from carpet start to become really relevant throughout time. And you can customize this table too. So this is a pretty cool feature that you can customize your table. So I'm just going to get one, same thing that we've done, just the element name here by lifecycle module. Okay, so we have this table. We're defining the impacts by lifecycle module, and then you can organize in the biggest impacts. We also have an option here to convert this to, just make this smaller so I can access the rest of the screen here. You can make this into bar charts like this. Just adjust the screen here again so you see the impacts by different life cycle stages using bar charts or pie charts. You can create using this analysis feature. So again, very handy for you to investigate where the top impacts are. You can also run the top impacts report. It's useful for start defining your initial strategies, defining the top impacts in carbon. So you can look at the impacts by materials and also transportation impacts, maintenance impacts, and also people and equipment. So very useful for early stage analysis, these reports and the analysis tab. One other important thing about early stage analysis, how you prioritize your strategies. How do you just bring up and improve the design here, an example. So this is a project we worked on, and during the feedback process, the initial analysis, what we do is we run a list of recommendations. So this is the recommendations tab here in the software, and you can see the list is quite comprehensive. There's a lot of different strategies here, from ceiling fans to heat recovery, solar PV, increasing the efficiency, changing set points for HVAC thermostats, and vertical transport, a bunch of different operational as well as materials strategies, improvement strategies. So at early stage, when you run these, the value for the design team is understanding the relevance of each improvement strategy. So we've got here in this column the percentage savings against benchmark, and we can see 1.3, 0.8, they all have different significance, right? So obviously we'll try to focus on the big ones first: solar PV, heat recovery, natural ventilation. In this case, it's all dominated by energy, so the energy strategies will have more significance. But this is really useful for design teams, because now they know, okay, this is important, but it's only 0.4% improvement overall. And you can tie this analysis with your cost plan and identify the biggest, the best bang for your buck, right? So look at the carbon savings achieved per dollar spent. So really, really useful at early stage analysis where you're prioritizing these strategies, looking at the contribution, the percentage contribution against the benchmark. So what we do here, we run the benchmark model here is the same building. We run a baseline building as business as usual, or the basic project documentation. And then we clone and create these strategies to model improvements. We won't go into much details about what you can do, how you model these improvements in the software and so on, because we already have other videos on this. If you like that type of information, I encourage you to navigate to YouTube or to our support site in the software and navigate through our videos. So we have here a bunch of different detailed explanation about modeling improvements in the software and so on. So that's regarding operational impacts and the tangibility when recording your recommendations. Show you one example about operational net zero carbon, which is very often not including the systems and services. So for example, if you're targeting net zero carbon for this building and you're adding solar PV, well, obviously here I don't have the operational modules turned on, so bear with me for a second. I'm going to focus on operational impacts for a moment, just energy. So remember, here we're still using the good energy, so a clean electricity grid as an example. And in this example, I've added a template for those that are familiarized with the software. I've added a template for a 100 kilowatt solar PV system. So we can see here that out of the total impact for this 1.6 tons per meter square, the contribution of the PV itself has been very small. So only 7 kilograms of carbon, 8 kilograms of carbon. And why is that? It's because you're connecting a solar PV to a clean electricity grid, if you like. So, oops, let me turn the services and the products impact as well, so you can see the significance of the embodied impact of, and also the recurring impact of your end-of-life impact of your solar PV systems. Okay, that's better. So what I'm showing here is when you're using renewable energy into your design, it's important that you capture the embodied impact of those systems as well. Okay, so as we see here, we have in this example particularly, it's showing us an increase in impact. And why is that? It's because we have a lot of impact initially from the PV. So we're looking at the inverter, the panels, the frame, the cabling. There's a lot of embodied impact here, and there's also recurring impacts because we are maintaining that system throughout time, changing the inverter. There's a warranty period in the panel itself. Excuse me. And we also assign the credit that you get from generating green electricity. So this is the annual demand that the panel will generate and the benefit you get. So the benefit here is reduced because you're connecting your PV to a clean electricity grid. So important here for future projections, when you're looking at 60, 100 years lifespan, it's really, really important that you understand the impacts of your systems, that you, when targeting operational net zero carbon, you also include the important impacts of your systems. Okay, so this is just another example, a little bit more details. I'm going to show you more about the target setting, which is an automated report we have in the software. This is the support article. So if you go into the eTool LCD knowledge base and type in target setting, you're going to get to this article. There's a whole description about the service, what includes in the precision and the accuracy of it. And there's also an example target setting report here, just to show you what it looks like. So the intent with the target setting report is to simplify things, right? It's to provide the relevant information early on and get the design team engaged. So we present the information in a simplified manner, where we're looking at bar charts for global warming potential, and you can also compare your benchmark to your design target to see the carbon savings here, around 8 or 7% for this example. You can also choose other indicators, net use of fresh water or financial indicator. And the report, we go through the basics of target setting, telling that it's not a full LCA compliant report. This is just a preliminary analysis. Gives you details on the building characteristics, the basic description. And this is important to highlight. So the accuracy of the target setting study is low, but it's adequate for approximating total life cycle impacts. Gives you that ballpark figure that we discussed earlier. Helps you understand the relationship between different life cycle stages. As we seen, product, should we focus on the product or transportation or end of life? It helps you understand hotspots and gives you tangibility for prioritizing strategies, and it will help you focus when you're investigating further. So this is the intent of the main intent for the target setting report, and it gives you some room for inputting the description of your building, and it gives you the preferred strategies. So a very basic table here with the list of the strategies, the basic description of these strategies. So cement replacement, for example, and then the percentage that it's saving against your baseline project. So in this case, 5% reduction for this example. So this is the format. Breaks down the recommendations in more details, so you can refer to assumptions and specs that you use for start quantifying the improvements. But again, a very basic report, only 10-page long and very simplified, so it's easy to read and communicate. Okay, in the software, when you're targeting your carbon reduction early on, you have the templates, the target setting templates, and this is useful when you don't know much about your project. So all you know is the floor area, for example, and you can start using this whole life templates to start capturing the initial impacts. So I'm just use one here, for example, whole building warehouse. Okay, so this template is built on a meter square basis. So this is 1 meter square of warehouse. This is a whole building warehouse, core and structure. So this is focused on lead, to do target setting for lead projects, because it's only capturing the core and structure components. So what we've done here is we model a whole project using bill of quantities or cost plan or detailed documentation. And then we do a reverse engineering to understand how much concrete is in per meter square. So how much concrete per meter square, how much steel reinforcement in foundations per, how many kilograms per meter square. So all this is based on a meter square. So what you do is when you load this template to your design, proportionally allocate the quantity, automatically calculates the quantities for you. So back to our benchmark office, I'll show you how this model was put together with only a few templates. So we used a template for the whole office building, the benchmark based on floor area. We used a template for the car park because it was not included in this initial one. And we used template for water, and I added the one for the PV. So when you go into this template here, you see that it's broken down into various components. So as I said, all the structural elements, stairs, services, windows. So it's very easy to get your model completed early on. So that's what I had today. I was hoping to have a few more, a bit of extra time to go through questions, but we still have, 5 minutes or so. I'm happy to stick around and demonstrate the software a little bit further or take questions. Let me just look at the questions here. Yeah, so what I'll do, this presentation is being recorded, and I will also send you all the links that I've shown you. They're all public information, so I'll send you the links as well after with the event notification. For comparison, for benchmark comparison, is it assumed that design life for 60 years? Yes. So when you look at your project details here for the benchmark, you go to your design life, and it's based on 60 years. I'm using default design life that's using most rating systems, which captures the recurring impacts. So Tom, answering your question there, yes. Okay, what did you click on to show the material table? Catherine Lee, before you show us the report. Okay, so this is the new feature in the software, is the analysis. This is it here. This is where I click on to get the materials impact. You can see here the new tab analysis, where you have different buttons here that you can click. So here's where you get the materials, the default settings, and you can use the custom pivot table here to scrutinize and look into the details further. How about at operational stage, a significant reduction of water can be achieved? Yes, that's a really, really good point. We didn't touch on water in this example, so it's focused on carbon emissions. Yes, we do have a lot of embodied carbon in water. Depending on the location, you have water supply, we have desalination, and also water treatment. So when you go into your operational impact, I've got water turned off here, but you can look at water as well in the same way. You can look at your water demand, and you can also look at your carbon impacts associated with water supply, as well as water treatment. So coders, yes, you can do the same approach. You're targeting water reduction and in consequence achieving carbon reduction as well. Thank you for the compliment. The presentation was good. And what makes eTool different from other simulation tool is eTool useful for the Indian climate. Yes, there's a lot of information on the website about the software and the features and how we are improving the tool. So I encourage you to navigate in the website and find out more about the benefits of the software. And it is applicable to the climate, different climate zones, because what we do here in the software when we're looking at operational impact is capturing the operational demand from software simulation tools like Energy Plus. So you run your energy simulation and you calculate demand. So you go in and you tell the design team, you know, the megajoules per year or kilowatt hour per year for that specific climate. And then with that information, which is regionalized, you can plug the demand, the energy demand in the software, and it will calculate the impact. So the important thing here is to have a regionalized electricity grid. So at the moment, we don't have an Indian grid, but we can add, you know, if you've got projects and you've got demand for Indian grids, then we can add to the data set. Now we've got the decarbonized functionality, and we see here the list of grids. It's very easy for us to get the data, the primary energy information, and the carbon coefficient and the other indicators for those grids and load them into the software. So thanks, Ashke, for the question and the compliment about the presentation. Yes, you can use this for Green Star compliance. Please reach out to us, send us an email or request a quote through the website, and we'll guide you through that process. We have done, I don't know, over 100, maybe 150 studies just for the Green Star market. We have a dedicated team in Australia working on that. So reach out to us and we'll give you specific guidance on rating systems. At what percentage completion you need to provide the data for in construction energy usage if you model when you have a completion project uses then space for 5% assumptions. Yes, so in terms of accuracy, you design, you improve your models as you progress your design. So the UKGBC document talks about that. You improving the accuracy of your models as you progress your design, and that gives you room to understand the relevance of energy and materials. So you can still make assumptions throughout the process until you get to construction stage, for example, when you start looking at specific products. And it's a different use of the software. So we didn't cover this in this section, but you can start looking at EPDs, for example. When you're looking at the detailed analysis, you can start replacing generic data with product-specific data using the EPD functionality and start defining construction specification. So a more accurate information at prior to construction. So yes, that's covering all the questions we had. Thanks everyone again for joining. We'll share the presentation and we'll share the links as discussed, and stay tuned. Please contact us if you have any other question, and we'll keep designing sustainably. Thanks again.